Hello students, today we will be discussing the chapter Reagents and Reactions. Organic reactions involve reagents and substrate. So chemical reagents bring about various type of changes in organic reaction to yield products of immense value. A suitable choice of reagent and the reaction conditions are essential for a success of a reaction for the desired product. So today in this session we'll be discussing about the few reagents that we use in organic reactions. The first reagent that we are going to discuss is DCC. Okay, first reagent that we are going to discuss is DCC. So what is this DCC? DCC is NN dicyclo NN dicyclohexyl carbo diimide or diimide. So this is DCC, NN dicyclohexyl carbodiimide is DCC. DCC is a powerful dehydrating agent. Okay, I will tell you the structure of this DCC. It is dicyclohexyl. So there will be two cyclohexyl rings. There will be two hexyl rings. Dicyclohexyl. NN. NN means both the dicyclohexyl rings are attached to nitrogen. N. N. Carbodiimide. So this is imide. C double bond, C double bond. So this is the structure of DCC. So if you are not writing the ring, instead of that you can write it as C6H11. C6H11 N double bond C double bond N C6H11. This is how you can write it. Okay, C6H11, nitrogen is linked to carbon. So this is the molecular formula of DCC and this is its structural formula. First, let us see the preparation of DCC. DCC can be prepared by oxidation of NN dicyclohexyl thiourea. Okay, so what is this NN dicyclohexyl thiourea? Let us see. So the preparation. Okay, NN dicyclothiourea, it is C6H11 NHC double bond S NHC6H11. So this is NN dicyclohexyl thiourea. NH2C double bond S, NH2 is thiourea. So what is the structure of urea? NH2CO, NH2 is thiourea. Instead of oxygen, if there is sulfur, we call it as a thiourea. So this is NN dicyclohexyl thiourea. So when you treat this with mercuric oxide, okay, when you treat this with mercuric oxide, so oxidation takes place. Okay, so the removal of hydrogen takes place here and the removal of sulfur. What is removal of hydrogen is called as oxidation. So this results in the formation of DCC, that is C6H11 N double bond C double bond N C6H11. This is the product that you are going to obtain. Okay, HgO gets converted to Hg2O. Okay, sorry, HgO, sulfur is removed, so hence it will be Hg2S plus water, this is what you get. So this is the preparation of DCC using the NN dicyclohexyl thiourea. Okay, so same product can be obtained by treating this, I mean NN dicyclohexyl thiourea with para-toluene sulfonyl chloride. Okay, so even you can, if you have C6H11 NHC double bond S NHC6H11, if you treat this molecule with para-toluene sulfonyl chloride, see, I will just draw the structure. This is toluene, so it is para-toluene sulfonyl chloride, I mean SO2Cl. So this is para-toluene sulfonyl chloride. So this can be written as para, P stands for CH3, C6H4, the ring, and SO2Cl in hot pyridine. Again, the removal of hydrogen or oxidation takes place, giving C6H11 N double bond C double bond N C6H11 plus H2S. Okay, so NN dicyclohexyl carbodiamide or DCC can be prepared from NN dicyclohexyl thiourea either by treating with mercuric oxide or with para-toluene sulfonyl chloride in hot pyridine. So this is the method of preparation of this DCC. Let us see the application of this DCC. Okay, what is the application of this DCC, or where actually this DCC is used? DCC finds application as a dehydrating agent, usually under mild conditions. This reagent is employed as a dehydrating agent in the synthesis of various compounds such as esters, anhydrides, amides, etc. So let us deal with an example in which we synthesize an amide by using DCC. Okay, see, synthesis of amide. Hope you all know what is an amide. So amides are the compounds which contain this group RCONH2 or RCONH groups. So these are referred as amides, generally RCONH2 groups. These compounds are generally referred as amides. Okay, let us see what actually happens in the reaction. Amides are generally prepared by the reaction between carboxylic acid and amines. Okay, when carboxylic acid is treated with amines in presence of dehydrating agent like DCC, amides are obtained in good yield at room temperature itself. Okay, when we use DCC as the reagent, so two molecules of as carboxylic acids will be used, RCOOH plus R dash NH2 amine. Amine are the compound that contains NH2 group amines. So two molecules of carboxylic acids and one molecule of amine will react with DCC. DCC is C6H11 N double bond C double bond N C6H11. So this one molecule of acid will react with amine to form amides. Actually, during the reaction, both the molecules of acid will be involved, but at the end of the reaction, one molecule of acid is what you get back. So when I discuss the mechanism, you will have a clear idea why I have written this as two molecules of an acid. Okay, so both the molecules of an acid will be involved in the reaction, but one molecule of an acid will be regenerated back. So what you get is, you get this compound amide is what you get, R C double bond O NHR dash NHR dash amide. So the molecule of acid, you will get back the carboxylic acid back. Okay, plus this DCC gets converted into dicyclohexylurea. It gets converted to dicyclohexylurea. That means it will be C6H11 NHC double bond O NH C6H11 is what you get. Okay, you get back dicyclohexyl. This is urea, C double bond O. If it is C double bond S, then it will be thiourea. So this reaction or the products of amide can be obtained in good yield by treatment of a carboxylic acid with amine in presence of DCC in DCC. Okay, let us discuss the mechanism of this. Okay, actually what happens during the reaction is what we are going to discuss. Okay, so how two molecules of this carboxylic acid will be involved and how we are going to get back the product is what we are going to discuss. Okay, let us discuss the mechanism. Mechanism is nothing but the steps that are involved in the reaction is referred as a mechanism. So what happens is here, the first step I'll write it as A. So one molecule of acid, so you know that acids are the substance that releases a proton easily. So this molecule of an acid will release a proton, and this proton will protonate the nitrogen of DCC. So we'll just write DCC. It is C double bond N double bond N C6H11 C6H11, right? So this H plus, it protonates nitrogen. Why it protonates nitrogen? Because nitrogen contains a lone pair of electron. So this nitrogen gets protonated. Nitrogen gets protonated. So what you get is here. What is the product that you are going to get? So you get RC double bond O, O minus will be left because H plus has been released, plus C double bond N double bond N C6H11 C6H11, right? This is that. So the H plus that has been released, it protonates this nitrogen. You get you get NH plus is what you are going to get. So you are going to get NH plus. Okay, next what happens is, since this nitrogen carries a positive charge, it pulls this lone pair of, this pi electrons towards itself. As a result, this carbon will be positively charged, so hence this oxygen attacks this carbon. That is, the negative charge on the oxygen attacks the carbon, and this electron shifts here. NH plus gets converted to NH, and a bond between an oxygen and carbon is formed. Why this oxygen will attack this carbon only? Because nitrogen is carrying a positive charge. So this nitrogen will be pulling these electrons. As a result, a deficiency will be created at the carbon. Okay. So next what happens is here, this has attacked here. So I'll write it here. So this is a reversible process. Okay. This is a reversible process. Okay. Next what happens is here, a bond between oxygen and carbon is formed. So it will be R C double bond O O. This oxygen forms bond with carbon C. There will be no changes here. Double bond N C6H11. When it attacks here, this moves here. That means this will be single bond NH C6H11. This is what you are going to get. Okay. Now, next what happens is, another molecule of acid will be involved here. So that also releases an H plus. We're getting this. So one molecule of acid is involved here. So it has released H plus, that is protonated here, and this has attacked the carbon now. So the another molecule of acid that is present, that also will release one H plus, and that H plus will protonate this nitrogen. Okay, so what happens is here, R C double bond O O C, this is as usual NH C6H11. Now this one, double bond N C6H11. So this nitrogen gets protonated, so hence nitrogen will acquire a positive charge. So this is what happens first. Okay, so protonation of nitrogen, then attack of the carboxylate ion, okay, resulting in the formation of this intermediate. In the next step, the acid that has released H plus, now what is remaining? R C double bond O O minus is remaining. Why? Because one acid is involved here, another acid has released a proton that has protonated this nitrogen, so this carboxylate ion is remaining. Then we'll attack this intermediate form, that is R C double bond O O C NH C6H11. Okay, C6H11 double bond NH plus C6H11. We're getting this molecule I have written. So what is this? This is another molecule of carboxylate ion. So after releasing a proton, the remaining part. So this OH minus will attack this carbon, and this carbon oxygen bond breaks. Okay, this carbon oxygen bond breaks. So C, it will get converted to double bond O. So what happens is, this pair of electron will move here. This is the change that occurs. See here what is happening. This is attacking this. So a new bond is forming. The old bond should break. So this bond will break. And the electrons here will go here to form double bond O. Okay. So a new bond is forming. The old bond should break. So this pi bond moves here and it neutralizes this. So what you are going to get? I'll write the compound. So this bond is breaking. Okay. So you are going to get R C double bond O C double bond O R. Okay, this bond breaks. Say R, C double bond O, C double bond O, R. And what is remaining here? This part, that is, we have C6H11 NH. So there is a C double bond O formed, and then NH C6H11. This is what is there. Are you getting this? So what you are going to get? You are going to get this compound, and such compounds are called as anhydrides. We call these compounds as anhydrides. So an anhydride is formed here. Okay. So what happens is DCC helps in condensation of these two acids. So when acids undergo condensation, so what is happening here? There is formation of an anhydride. An anhydride is formed. So what happens is this anhydride that is formed here will react with amine to give you an amide. So the anhydride form is RC double bond O, OC double bond O, R. This anhydride formed here, it will react with the amine, that is NH2 R dash, whatever the amine that we'll be using, because in this reaction we'll be using 2 molecules of acid and 1 molecule of amine along with DCC. So what happens is this H plus, this nitrogen attacks the carbon here, and then the bond breaks. So directly I'm going to write the product. So this H and this RC double bond OO, so they'll go as an acid. So this nitrogen with a lone pair of electron attacks here. Actually the nitrogen contains a lone pair of electron. It attacks the carbon. It can attack this carbon or this carbon, both are same. So it will attack the carbon. So when it is forming no bond, so this bond should break. So this bond breaks. So this group goes off, R C double bond O, that will take up an proton from nitrogen and it forms acid. So what you are going to get is, you are going to get this compound. It is R C double bond O NH R dash plus R C double bond O OH. Okay, so what you get out, what you got amide as a product. So this is the use of DCC in preparation of amide from carboxylic acids and amines. Okay, it used as an it helps in dehydration. So it is used as a dehydrating agent. So what happens? So one molecule of acid will be utilized first. This H plus will protonate the nitrogen, and this carboxylate ion attacks the nitrogen. Then the H plus from another acid will attack the nitrogen, and that carboxylate ion will attack this carbon, resulting in the formation of the cleavage of this bond, and an anhydride is formed, and an urea, dicyclohexyl urea, is formed. This anhydride reacts with amine to give you the corresponding amide. Okay, so this is the use of DCC in preparation of amide from amines. Okay, hope you have understood this, students. Thank you.